Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine if two functions are inverses of each other. And again, the way to be able to determine if two functions are inverses of each other is we're going to have to compose them, both f of g of x and g of f of x. That means plug each function into the other function and then simplify. And if we can simplify to get the identity function, which is just x, then we can show formally that, or prove without a doubt, that two functions are inverses of each other. But we have to be able to compose both ways, all right? Because two functions are only inverses if f of g of x equals x and g of f of x equals x. It only has to work with both of them. That's the only way we can prove for sure that they are inverses of each other. So basically what we're going to do is, for the first example here, we're just going to do, make sure I have them still here. Good. So what I'm going to do is I'm just going to do f of g of x. And again, if we can simplify this to give us to x, then we can show that these are inverses of one another. So to do that, remember f of g of x, composing function, basically what we're doing, what this tells us to do, is plug the g of x function into the f of x function. Now you can see here, the g of x function is 3 divided by x minus 4. So when I plug it in, I'm going to put parentheses around it. So basically what you want to do is you're going to plug the g of x function in for the input variable of f of x. So I'm going to do 3 divided by, instead of writing x, I'm going to write g of x, which is 3 over x minus 4. And then I'm going to subtract that from 4. Was that my problem? Did I write that right? Oh, that's plus 4. I knew I made a mistake. That one's plus 4. I was like, that's not going to be inverses anymore. OK. So now the reason why I knew there was a problem here is because I knew that these had to add up to 0 if they were going to be inverses. I was trying to think ahead. So basically, ladies and gentlemen, what we look in here is, well, we really don't need brackets around this here anymore. We can kind of get, I just show the brackets to show that I'm plugging this function into the other function. But we don't really need the brackets anymore. And you can see that now negative 4 plus 4, that's just going to add to 0. So therefore, I'm left with 3 divided by 3 over x. Now this one gets a lot of students because you have a number divided by a fraction. Now what do you do? Well, whenever I'm dividing by a fraction, I always like to think about that as get rid of it by multiplying by your reciprocal. So I'm basically just going to multiply by the reciprocal on the top and the bottom. Well, any number multiplied by its reciprocal goes to 1. And then I have 3 times x over 3. So let's look at that. 3 times x over 3. Well, really 3 is 3 over 1. The 3 divide to 1, and we're just left with x. So there you go, ladies and gentlemen. Now I show the x. But remember, we have to show it both ways, right? We have to do f of g of x equals and g of f of x. And I kind of ran out of a little space, but I know this problem's not going to take a lot of work, so let's do it over here. Actually, let's do it a little bit higher. So let's do g of f of x. So now I'm going to plug the f of x function in for x in the g of x function. So again, the key is using parentheses. So it's going to be 3 over x. Well, now that's going to be f of x. So that's going to be 3 over parentheses 3 divided by x minus 4. And then that's going to be plus 4. OK, so this one can kind of get students confused again. Because basically what we're going to want to do is, again, now you have a number, again, that x is being divided by a fraction. So again, just like we did over here, let's multiply by the reciprocal. Well, in this case, the reciprocal is x minus 4 over 3. X minus 4 over 3. Hopefully you know, again, reciprocals are going to multiply to 1. Here, again, I have 3 times x minus 4 divided by 3. Well, just like over here, the 3's are going to divide out. So therefore, I'm left with x minus 4 plus 4. Well, guess what? That's just going to now add to x. So now, ladies and gentlemen, you can see by composing the function for f g of x and g of f of x, I get the identity element x. So therefore, I am good. Now, let's go ahead and look at this one. And the reason why I kind of left it, I'll do this in red here. So now, we're going to go through the same process. So let's just do f of g of x. Now, I chose the problem here, so I know this one's not going to take as much work as this one. So now I'm going to plug g of x in for x, well, or f of x. Well, f of x is just x. Right? So when I plug this in there, I get 1 over negative x. Well, ladies and gentlemen, that's not your identity element x, right? So automatically, you can just even look at that and say, oh, well, when I plug one function into the other, it's not going to give me x. So this one is not inverses. OK? It's not going to be inverses. Well, let's go ahead and take a look at this one. So now, again, just going through the process here. Let's use blue again. I like blue. So first thing we're going to do is do f of g of x. Now this one, I can't tell just by initially looking at it. So I'm going to have to go through the work. And a lot of times on a test, you're going to have to go through the work anyways. So now I'm going to plug g of x in for x. So instead of writing x, I'm going to use parentheses. I'm going to do x squared plus 2 minus 2. OK? Again, we don't really need these parentheses here. I just showed the parentheses to show that I was plugging one function into the other. But here you can have 2 minus 2. So it's going to be square root of x squared, because that's going to 2 minus 2 is 0. Then the square root of x squared, well, that's just going to leave you with x. OK? So it works for f of g of x. Now let's go ahead and try g of f of x. So therefore, I go g of f of x. So now I'm going to plug in my f of x function in for my g of x function. So that's going to look like square root of x minus 2 squared plus 2. OK, well, I can't really do too much. However, I noticed that the square root and squaring, those are going to be inverse operations. So therefore, those undo each other. And I'm just left with x minus 2 plus 2. Well, negative 2 plus 2 is just going to give you 0. So it's just going to leave me with x. So therefore, ladies and gentlemen, the first function and the last function, we can prove that they are inverses. However, by using composition, my middle two functions, we can show that they are not inverses of each other. So there you go, ladies and gentlemen. That is how you determine or prove that two functions are inverses of each other. Thanks.